But I was there in previous.
I put them yesterday before I slept. I've just drawn this again to show you that as you are having these incident vectors in the form of our incident wave, reflected wave, and this being our y, then our x, and then z. Then we say that EI would equal to E naught x, E naught I, the exponential, so exponential. Do we use J or Y? J. So J, then this would be the same as KZ minus omega t, and since we are in medium 1, we add KY. Then for the HI, this would be the same as HI is along the Y, H naught I, exponential J, we are in medium 1. And then for reflected part, we have E. What would be the reason why people are around and they are still outside there? Here. To who? Then EI, sorry, ER would be the same as this would be along the XT, and then would be E naught R exponential J. We are still in medium 1 because everything gets reflected back to medium 1. Z minus omega t. And then we go to the HR. HR, we say this would be the expression of lateral inversion. So what is on the left goes on the right. So what was going to the left, to the right, when it is reflected, it goes the opposite way. And that's where we got the minus y roof, h naught r, exponential j. We are still in medium 1, this way. And I've drawn this part in 3 dimensions to show you how the place is. And then finally, the transmitted part would be this x, sorry, E would be still along the x, E naught for amplitude, then T for transmitted, R for reflected, I for incident. And then exponential J. Now we cross, we get transmitted across medium 2. So we get K2Z minus negative. And then HT will be equal to, it will just get transmitted through as it was, goes through the medium. And then it will be still along the Y, H naught T, exponential J, medium 2, so K2 Z minus omega. If you want to keep it in a vector form, you will be having the K1 dot Z and K2 dot Z. And we say this goes back to K1Z and K2Z by applying the dot product, which eventually will end up in Kz, given the nature of the K and the Z being along the same direction, and the dot product will be the product of the magnitudes and the cosine of the angle between them. So continuity of the tangential component, of the E is given by N1 imply that E naught I plus E naught R is equal to E naught T. This will be our equation 1. Since there are no surface currents, the tangential component of H is also continuous. Tangential component of H is continuous. If it is continuous, then we shall say that N12 cross H2 minus H1, which should have equal to Js is equal to 0. And this will be for perfect electrons. So this would mean that, like we did up there, Hi plus Hr would be equal to Ht. But if we now express it in terms of the amplitude, then we get the negative. So I beg to rub my nice diagram. Then I substitute such that this would imply that H naught I minus H naught R is equal to H naught T. And this one becomes our equation 2. But from earlier computations, we said that we can get H from root epsilon over mu E, implying that H naught I will be equal to epsilon 1 over mu 1 root E naught I. H naught I is still in the medium 1, epsilon 1 over mu 1 root E naught I. But when we get transmitted, H naught T will be equal to root epsilon 2 mu 2 E naught T. So we have the equation 1 being the same as E naught I plus E naught R equal to E naught T. H naught R minus H naught R equal to H naught T. So this is equation 2, equation 1. And then anyone have any issues here? So equation 2 becomes, equation 2 is the H, yes.
Since it is in a different direction, does that not have an effect on the sign of the other part of the equation? Or does that work when we consider image I?
just expressing what is going on. We are getting the amplitude of the reflected E plus the amplitude of the reflected, H, incident H, plus reflected H should be equal to the transmitted part. And when it was reflected, the amplitude was in the other direction. So that's how the minus comes. Yes, amplitude is not always the magnitude, because when we are looking at our wave, the amplitude is both here and which is both plus and minus. Okay? It's the magnitude which is positive. And the amplitude can be either in the positive or in the negative. Shivira, do you have a console? So before we go far, I have a decision to make. I first marked instrumentation, I finished. Put on Mwere and then things are ready. I marked 3/4 of Tare 1, Tare 2. I have marked 20. So let me see. So all these are marked and with marks. But then I have these ones which are not marked. So I don't know which one I will do, whether I will give those who are marked, and then those who are not marked, you wait for me, or you all suffer until probably tomorrow when we are doing. I can give those who don't do instrumentation. Those who do instrumentation, I give. But that is on the account if I have marked. What else did I want to say? So I finished the order for the body, and I accepted that it's chicken.
Chicken.
What else? No, those are the things I wanted to say before I move on. Okay, so
What do we mean the related work?
there
What do we mean the vegetarian?
you leave the salad and the vegetable smoothies. That's
I'm a
it.
freshman. I'm a freshman.
You are a freshman. I have noted that you are vegetarian. So I will give your chicken to Fred and then his salad to you.
I'm not.
It is on record, you say it on record that you are vegetarian. So your chicken is for Fred salad, make your vegetarian
I'm not a
meal.
It's not on record. It's not on record that my salad is for you.
It is on record. You don't want your salads to go.
Everything is mine.
Okay, they are extra. There is what they call when you budget, what they call miscellaneous. So the miscellaneous salads will be for you, but the chicken will be for you.
Yeah. No.
You still don't want the chicken, you see.
I want everything.
Even the
Okay, let's first finish what brought us. So, if we now use equation 2, which is this equation here, then we shall say that H and I is the same as root. So equation 2 becomes, I'm just doing algebraic gymnastics. It's nothing much that we are doing. The physics we already finished by identifying how an incident gets reflected and transmitted. We are now just doing the algebraic gymnastics. So the equation 2 becomes these two here, H and I is root epsilon 1 mu 1 in Ri, then minus H and R, so this would be epsilon 2 mu 2 in Ri, and this should be equal to the transmitted H naught, which would be root epsilon 2 over mu 2 E naught. Okay. And this constitutes our equation 3. This is equation 3. It is laborious to write these things all the time. Root this over this. So let's put eta. Some of you call others call it coefficient of viscosity. This is eta. So let's put eta 1 equal to root epsilon 1 over mu 1 and eta 2 equal to root epsilon 2 over, so that we make our life very easy. And so equation 3 becomes eta 1 in Ri minus eta 1 in Ri equal to eta 2 in Rt. We shall call this one equation 4. Using equation 1 and 4, using equations 1 and 4, equation 1 is nRi plus nR equal to nRt. So this would imply that we shall get the eta 1. What did I say? Using equations 1 and 4, we can solve for. So we can solve for using senior 2 math. We can solve for nR and nRt. And nRt as follows. So we can say, if we use
instead of writing E 1 over mu 1, you've written E2 over.
here. This is still 1 because we are in medium 1. And this one, we've just done that, and I don't see any other problem. This is still in reflected is in medium 1, so it should be epsilon 1 mu 1. I think the rest is okay. Yes. We can solve equation 1 and 4 simultaneously to be able to get nRt and nR. So multiplying multiplying eta 1, multiplying eta 1 by equation 1, we would get eta 1 in Ri plus eta 1 in Ri equals eta 1 in T. That would be equation 4. I've skipped a step in the notes whereby you multiply first, then expand. Don't worry about it. If I got these two, these 5 and 4. If I add them up, I would eliminate E naught. If I subtract them, I would eliminate E naught. Solving 4 and 5 simultaneously, you can get E naught and E naught. So I'm not going henceforth to waste my time. I'm going to rush and get whatever I want, and then in your time, as you revise for the exam, you should be able to chop everything. So adding equations 4 and adding equations 4 and 5. Then when you add them, the minus in R dies with the minus error 1 in R, so we get twice error 1 in R being the same as the error 1, since this is error 1 and this is error 2, so this would be error 1 plus error 2 in. So now we can get in T in terms of the, so this would be 2 error 1 over error 1 plus error 2 in R. This would be our equation 6. If we multiply the error 2 by 1, we will be able to relate and add or subtract, whichever way we do it. We will be able, if we multiply by error 2 and subtract, we will eliminate the T, the inner T, and then get the inner R. In terms of the inner I, when we get E naught R over E naught I, we get reflection coefficient. E naught T over E naught I, we get transmission coefficient. Also, error 2 multiplied by equation 1 gives error 2 in Ri plus error 2 in Ri equals to error 2 in at T. This is equation 7. Equation 7 minus 4. Equation 7 minus equation 4 yields error 2 minus error 1 in Ri equal to error 1 plus error 1 plus error 2 in R equals 0. And making in R the subject would be the same as error 1 minus error 2 minus error 2 over error 1 plus error 2. Write it down if there are names. This should be in out. You just get a piece of paper and chop them, they come up easily. This is equation in general. Is it n2 plus what?
That symbol
This one here?
Yes. No, the upper
we are subtracting 7 and 4. Anyone who remembers what 4 is? It is 1 and it is 1 and 2. We can't have, if they were to be, it should be 2 plus 1. You are so bad. In general, we had the expression for the average, time average Poynting vector, which was a half epsilon over mu E naught squared dot z. So this will be simply z, since we shall be getting that as magnitude. We can't dot it with a vector. So SI will be the same as medium 1, for instance. So this will be a half root epsilon 1 over mu 1 E naught I squared z. The reflected one will be a half. We are still in medium 1 E naught R along the z, because it is propagating the right-handed product. Then the transmitted one will be a half. This is across to the other medium, so it will be epsilon 2 over root 2 E naught T squared. There is a square here, and then it is along the z. This is just to take you back to the Poynting vector if you are having such a transmission. But we need to know the reflection coefficient and the transmission coefficient. How much is transmitted? How much would be reflected? Ajat, how many times have you dodged me in the lecture? Winnie, how many times have you dodged? Our records. Do you know? Can you guess? I can tell you, I have the tally here. All things are here. This file is just for records. It has no notes. These are just attendance for electromagnetism and electronics and instrumentation. Now, reflection coefficient R is defined by the ratio of the average Poynting vector of the reflected dot z divided by the average Poynting vector of the incident. And we take the magnitude. So this would be the same as R being equal to, we say this is a half, it is reflected, it is medium 1, and then the amplitude is E naught I squared, no, R squared, and we are saying so it is along the z, and we dot with the z, and then we divide by a half root, we are incident, epsilon 1, mu 1, in the incident it is E naught I squared, it is along the z, and then we dot with the z. When we start with z, it's 1 times 1, cos sign of 0, the angle between them, so everything disappears. So we get, therefore, our R will be simply, these would go, so we get E naught R over E naught I, and this would be square. This definition here is our equation 9, and then this result here will be our equation T, 10. Of yes, but inside it is n2 either 2 minus either 1. True? And for me, I just remove the negative and say either 2 minus either 1. Are we okay? Good. So using equation 8, which was for E naught R equal to error blah blah, then E naught I. Here they say above, I don't know whether it is your above. Previously, R would be the same as eta 2 minus eta 1 over eta 2 plus eta 1, and then this was our ratio E naught R over E naught I, but it is squared. So if you are asked for reflection coefficient and you are given all these other things, the epsilon and mu, then you can get the reflection coefficient from this equation 11. How much would be transmitted? How much would be transmitted would be given by the transmission coefficient. So the transmission coefficient T, transmission coefficient T is defined by T equal to these other things. So it would be T equaling to ST over this. This would be E naught T. And since we are transmitted, this one would be medium 2. And this one is still medium 1. This would be different. The difference is that this will be equation 12. Then you substitute in. After substituting in, then we get, yes. Is it all right now? So then we get T would equal to, this is halves would go, they are up and down, but then we would have now eta 2 over eta 1 for this part here, and then this ratio here would be, so this would be E naught, so these ones are 1 to 1, and then we get the E naught T over E naught I squared. 6 above, this is not above, using equation 6 previously, this above is always very confusing. Even in the textbook, you can't see it above, it is somewhere previously. But equation 6 is, for purposes of reference, the P naught T equals to 2 eta 1 over eta 1 plus eta 2, then P naught I. Thus, this implies that T, which is equal to eta 2 over eta 1, then this one, this P naught over this square will be in with 2 eta 1 over eta 1 plus eta 2 squared. And this would be the same as, this would be equal to 4 and this will be now eta 1 squared, eta 2 over eta 1 plus eta 2 squared eta 1. And if you do the simplification, 1 eta will go, and if 1 eta goes, then you can remain with down, it is only the bracket surviving, so you would get therefore T will be equal to, this goes with that, the rest has nothing to go away. So it becomes 4 eta 1, eta 2 over eta 1 plus eta 2 squared. This is the transmission coefficient. You gotta note that the transmission coefficient plus the reflection coefficient are like probability. They never go beyond. So I should never give you a number and then you get T equal to 12 and then you underline and I see you getting out. I may not see you, but if I'm marking and I find you go 12 and underline, I will call you during Christmas and gain you out. Assuming there is such a number, it is a criminal to get probability equals 10 and you also go out of the exam and I got probability, it was 10. You are innovating, you are creating your own probability. You can't have probability 10 times occurrence. When everyone knows that it is hard to have the thing even once, and when for you are making it 10 times. That is a criminal. It's a criminal offense. You should be jailed for such a crime. Now, for non-magnetic mediums, then we have that the mu 1 will have equal to mu 2 and will equal to, if it is non-magnetic, what do we get? We get mu naught. Eta 1 will be equal to the root epsilon 1 over mu 1, and this would be the same as the root of epsilon 1 we said is equal to n1, which is the refractive index, and this would be, and we have said that mu 1 equal to mu 2, which is equal to mu naught. So this will be equation 15. had we gotten equation 14? Equation 14 is this one here. 13 is the one over t equal to either 2 over either 1 u naught over u naught I squared. 12 is the definition of the SI. And then either 2, which is equal to epsilon 2 over mu 2 square root, will be the same as the square root of epsilon 2, which is n. This is n not eta. n2 over root mu naught. We label that as equation 16. So if we use the equations 15 and 16, now we can get new expressions for R and T, depending on what they chose to give us. Whether they chose to give us the conductivities and permeability or the refractive indices of the media. So using equations 15 and 16 in equation 11 would yield that R is equal to N2 minus N1 squared over N1 over N1 plus N2 squared. Then this one comes. And then also using equation 15, also using equation 15 and 16, equation 14, then T, which was equal to 4, either 1 would be N1, N2 over the N1 plus N2 squared. This is equation 18. And I request that you do example on page 150, 59. Do example on page 159. And it says you draw the diagram of a plane electromagnetic wave propagating in a dielectric medium of refractive index N1 is incident normally on a plane boundary separating the medium from another dielectric of refractive index N2. The diagram showing the orientation of the E and H field intensities for the incident, reflected, and transmitted. What I did here. Determine the reflection coefficient if refractive index ratio of refractive indices of 1 medium 1 to medium 2 will equal to 3 plus 2 root N2. So if you have N1 over N2 equaling 3 plus 2 root 2, so then you can make sure that you get those ratios here. So you can have dividing by N1 here by N1 here, N1 here, N1 here. This would be the same as N2 over N1 minus 1 squared over 1 plus N2 over here. So this one is equal to, this one here is this. But this one is the reciprocal of this, which is 3 minus 2 root 2. And then you substitute in, you get the reflection coefficient in the example. And the reflection coefficient will end up being 0.5. Transmission coefficient will be 1 minus 0.5. That marks the end of, no, not yet. Not yet. The end of the section of Poynting vector, no, not Poynting vector, but propagation of electromagnetic waves on normal incidence, cross and interface of perfect direction. So we got the final part of the course, which makes me excited. You know, the moment I say this is the end of the course, I'll be the most excited person because I have finished the course in time, even when I missed the 2 weeks. I just enjoy the course. I don't know about you. Enjoy your what? Just choke. I don't think you should just choke. You should also try to enjoy. Unfortunately, it is over.
Show more enjoyment.
Talk slowly. If you just talk like that, I may...
You may change.
So, you just have to hold your chin like this and say, we don't know. So that I can say, my people are dying, let me make them happy. But he said, we got a job. So finally, we look at the propagation of EM waves in conductive media. So we are now trying to chrome this one up with this our banana cable. Here. This is now where we are ending up. So in the linear homogeneous, which is uniform, homogeneous, and isotropic conductor, then we know that the electric displacement vector is given by the epsilon E. The magnetic flux density can be looked out in terms of the permeability and the magnetic field intensity. And by Ohm, we can relate the conductivity of the material or of the medium by looking at the electric fields. And so, considering Maxwell's equations, then the curl of H J plus Kali D by Kali T, which is the correction that Maxwell did for time varying fields. This would imply that the curl of H would be equal to J, which we have said is, and then add on the epsilon Kali by Kali T. Since the divergence of the curl of H is equal to 0, this would imply that the sigma divergence of E plus epsilon Kali by Kali T in divergence of E would also equal to 0. But Gauss said that when you are trying to diverge the electric fields, beware of the charge density you got and the permittivity of the medium in which you are trying to do this scenario. But Gauss says that this is equal to epsilon if the epsilon is a constant in our homogeneous medium. Therefore, we will have that rho E sigma of epsilon plus Kali rho by Kali T will be equal to 0. The solution of the above equation, rho T will be equal to rho naught exponential minus T over tau, where tau equaling to epsilon over sigma is the time between two consecutive knockings during conduction, which we call the relaxation time. It's not the surface charge density. And for conductors like copper, this time tau is approximately about 10 to the power minus 18 seconds. And you won't find any charge density inside conductors. That's one of the ideal properties we talked about when we were looking at ideal conductors. Inside a conductor, which is perfect or ideal, you have equal positive and negative charges. If there is any charge that is dissatisfied or residing in there, it can only be found on the surface. And it would constitute a field that is normal to the surface. Maxwell came up with now equations for conductors. So Maxwell's equations for a conductor of conductivity sigma and rho equation 1 of Maxwell, then the curl of E equaling to minus Kali B by Kali T can be written as the curl of E plus mu Kali H by Kali T equal to 0. This is the same as curl of E equaling to minus Kali B by Kali T. But the divergence of E will be equal to 0 because there is no surface charge density within this conductor. And finally, when you try to divert the magnetic fields, you destroy everything. And this is the equation. We can try to fit the field vectors in here and see what happens. We are bad over there, so don't feel like. So consider equation 1. Consider equation 1 and take the curl. So when you take its curl, this would be the same as, so the curl of H, so we get the curl of H minus
I'm asking for clarity as to why the row the row is
equal to 0. This is, are you comfortable that this is a perfect conductor, this wire? And what would be the charge density inside the conductor? The properties I asked for them in this test 1. I call it test 1 because there will be test 2 and test 3. We still got time. Is that okay now? Y rho is equal to 0?
yes.
Is it okay now?
Expression, okay.
It is, we are looking within a conductor. For a conductor of conductivity this and rho equal to, with rho actually, in the node cities, with rho equal to 0 are?
You're looking at inside the conduct.
The conduct does not conduct outside. A wire does not conduct outside. Conduction takes place inside the wire. When I say I am having this wire conducting, transporting my image from the TV to from the deck to the TV, the image is going inside the wire. And inside the conductor, you don't find any charge density. Even if you took it backwards, the divergence of E equaling to rho of epsilon, there is no electric field density inside this conductor. So rho still goes to 0. Fame. Are you okay with that? So if we take the curl of this would be minus epsilon, Kali by Kali T, the curl of E, and then it should be equal to the sigma, then the curl. So I will not waste too much time here. So this would imply that it is divergence of H minus grad squared H, so using the identity, then plus the epsilon mu grad squared H, Kali T squared equaling to minus sigma mu Kali H by Kali T, when you substitute for the curl of E here, implying that you got the grand squared h minus epsilon mu Kali squared h. I had made the cos 2 simple, so let me complicate it a bit. Kali t squared minus sigma mu Kali h by Kali t equal to 0. This is when you are having conduction. So we had equation 1, 2, 3, 4. This is our fifth equation. If we consider equation 2 and take the card, I'm just trying to write very fast and not very fast, pretend that it is becoming complex, but there is nothing complicated about this course, and I wouldn't want to hear any one of you teaching in secondary, and then they tell me that you are saying that electricity is not easy to teach or is not an easy section. I'll come for you after spending all this time. So consider equation 2. So equation 2 is here. We are taking the curl of E plus mu Kali by Kali t, the curl of h, equaling to 0. Then we do the right gymnastics. And so this would be grad divergence of E minus grad squared E plus mu Kali by Kali t in sigma E plus epsilon Kali E by Kali t equals to, but for a conductor, divergence of E equals to rho of epsilon, which is equal to, therefore, we come up with grad squared E minus mu epsilon Kali squared E by Kali t squared minus mu sigma Kali by Kali t equals to 0. And this is equation 6. Assuming the field vectors E and H are of the form which we had, today we are finishing at 6. That's fair enough. Pardon? What's wrong with Chibira?
You see, you can't talk. It is not
assuming the field vectors, E and H, assuming the field vectors E and H are of the form, which we had is it yesterday or the other day? Yesterday. ER of T equaling to E naught exponential J K dot R minus omega T, which was equivalent to ES R exponential minus J omega T, and then HR at T equals to H naught exponential, this is a vector, exponential j k dot r minus omega t, which is equivalent to hs r exponential minus j omega t. Consider equation 7. Consider equation 7. 7 is here. 8 is here. Grad squared E will be equal to minus k squared E, and carry E by carry T will be equal to minus j omega E. Carry squared E by carry T squared will be equal to minus omega squared E. Substituting in this equation here, so this equation below, the equation 6 becomes minus k squared wave plus omega squared epsilon mu plus j omega sigma, j omega mu sigma E will be equal to 0. So if I substitute for grad squared E, for carry squared E carry T squared, and carry E by carry T, then I will get that. And when I get that, then I say that k wave squared will be equal to omega squared mu epsilon plus j omega mu sigma, implying that how do you call this in mathematics? Is equal to omega squared epsilon mu E mu 1 plus j sigma over omega epsilon. And we have a few things to note about this expression. One, this k wave, which is equal to the kr plus jki, the imaginary and the real, is generally complex. Not complex that it is complicated, but it is a complex variable which is having both imaginary and real, whereby this imaginary is that squaring that imaginary gives you minus 1. 2. For a good conductor, sigma over omega epsilon is much greater than 1, and this is referred to as the large loss limit. The large loss limit. As you transport the things here on the antenna cable. 3. In non-conductors, sigma over omega epsilon is much less than 1 and is referred to as the low loss limit. router has that rubber. The reason they put that rubber bit on the antenna is to make sure that it does that purpose. 4. The 4th note. Note 4 is that we do all this and use what we call the Q factor. So the quality factor of the medium, is defined by the quality factor being the same as the Khalidi by Khalidi over the J sigma free. This is our equation 10. And this actually is given by the displacement current density, the Khalidi by Khalidi by the conduction current density, J, conduction current density, J free. And this is where the electric displacement vector is sigma E, and the J equals to sigma E from microscopic form of Ohm's law. Now, for a wave being propagating in the form E is equal to E naught exponential J kz minus omega t, which we were putting as E is equal to E naught exponential J kz minus omega t. Then we would have that the Khalidi by Khalidi is the same as minus J, because this is the same as differentiating partially epsilon Khalidi by Khalidi. So this would be the same as J omega, then the epsilon E. And so therefore, our quality factor would be the same as the Q, which is equal to Khalidi by Khalidi, which we have just got, divided by the sigma E, which would now end up with being omega epsilon over sigma. And this is our equation 11. For non-conducting media, like rubber, non-conductors for that case, or insulators, rubber, plastic, you have conductivity being 0. And if you have conductivity being 0, what would be your quality factor? If this is 0, infinite. So this would be large as. For good conductors, Q is very small. Q is very small because you does that come about? So we have like 10 pages left. But we still got time. It's not yet even before the but I can stop here if you want. I can say I declare the course closed. Consider a plane electromagnetic wave. Consider a plane electromagnetic wave with the electric field vector E propagating along the Y, and then we have exponential J KZ minus omega T. Incident normally from free space on to an infinite, plane of a good conductor, assumed to be non-magnetic. Thus equation 6, which was the Bragg squared, that equation in the conductor, equation of solution of, not solution, but that equation of the wave within the conductor. So thus using equation 6, we would get that minus k wave squared plus omega squared mu epsilon plus j omega mu sigma E would equal to 0. Zero. Are you taking notes? Or you have them on the way? I am not a prophet. I am not a bad omen. But it will be very tricky. If you come here and see it, I chop stuff, then you keep looking at your phone. I will use my Mwere notes. You even download them to your phone, and then when it is on the 27th, the phone kaputs, like it just collapses. No, you got it, but it just it dozes off. So this implies that k wave squared will be equal to omega squared. I'm just doing algebraic gymnastics. E 1 plus j sigma over omega epsilon. For a good conductor, we would have that sigma over omega epsilon is much, much greater than 1. implying that our K wave squared would equal to omega squared epsilon mu. And this would be, if it is much greater than, so 1 is negligible. So you remain with sigma over omega epsilon, then you got a J.
Yes.
And then this would imply that K wave squared equals to J omega mu sigma. We can now say that K wave squared equals to omega mu sigma exponential. J is the same as J pi over 2. Because E J pi over 2 is the same as cos pi over 2 plus J sin pi over cos pi over 2 becomes 0. J sin pi over 2 is 1. Still you get back to J. So this would imply that K wave is equal to, we take the square root, so this would be omega mu sigma to the half, and then this one, when we take the square root, it becomes J pi over 4, because we are multiplying by half. The pi, the J is the same as exponential J pi over 2. That's mathematics. So I can now say that this would imply that K wave squared is, K wave equals to omega mu sigma over 2 to the power half. And then I get this as 1 plus J. And this one will be equation 12. And then I let some factor alpha equal to omega mu sigma over 2 to the half. Then I will get that K wave equals to alpha E mu 1 plus J, which is the same as the KR plus J, KI. And then I will get that in this character, anyone having issues of how we have, this one is okay.
No, it's not okay.
Huh?
I don't know how we get that part of the plan.
Do math? Okay. J, we've said is equivalent to the exponential J pi over 2. Is it true? What we're headed by is the one I'm asking. Is that true?
Yes.
Huh?
If it is equal to that, then that one is true.
So you're okay now? Good. Thus, in the character, what I'm saying is right. You hear him later. With E being the same as Y E naught exponential JKIZ and EJK RZ minus omega T. Then we got the, or you can write this as being the same as, so this would imply that E, I don't want to do the other one, you will find it in where. This would be Y roof, and then you have E naught exponential minus alpha Z exponential J alpha Z minus omega T. This is for the electric field. sat down and did all this stuff. After the juju, they made sure they get equations for it. Whenever you get, when you know rich men in town, if you phone Chirumira, he will try to tell you how he works hard, but himself he doesn't know how money comes sometimes. But he will try to explain, you know, I am a hard-working man. I like networking. One time the whole district's money landed on his account. Chirumura. The whole district budget went on his account. In Baroda. So, some people will not tell you exactly how they get money. But they will explain, you have to be networking, you have to work hard, you have to wake up early, you have to be at work before everyone is there. So that you have your blessings. So they look for all reasons to explain their juju. True or false? They will tell you when you are a businessman, wake up early, no one should see you doing this, make sure when you have, don't greet people anyhow, all those things. Now if you do those things, you don't see money come more. So you can imagine guys doing all these things, putting alpha, putting KR, what, just to explain how transmission is, how propagation is taking place. And then we are here, we solve them, we do them, we understand them, and still we see the wire, we just hold and put. And by God's grace, we see the image of the TV, and we enjoy. We enjoy the Commando movie. We are done. So, the earlier you respect your own way of doing things and you make them, I've already done my part. This course I was going to have the best course done except for yesterday. When the camera, is it yesterday? When the camera just refused. It said, today's work is all nonsense. Don't put it is not going to be seen. And I took it in good faith. I don't know what I said in the video that I was not supposed to be on record. I don't know. Did I say anything funny? So yesterday's things are all off. I am not even feeling it. You never. So, but what I'm trying to say is that in the morning I was watching the video of electronics and instrumentation, and I can't believe that I'm the one who was saying things nicely the way I was saying it. This is as far as 2017. It was as if it was yesterday. So, when I feel I'm no longer energetic right on board, I'll retire. And go and grow some maize, eat it. Hey, by the way, there want to be maize. I thought it would. You know this maize which had dried up, how do you call those things which come out of the thing, of the corn? This is the corn. There are these hair. It is hair. You are all fake. How can it be hair? This thing which comes out, it had dried up, so I thought it would be ready. Now there is a fresh one coming out of the thing. So I am very disappointed.
Just eat.
You check. Just eat.
You just eat.
Check.
Wow.
You bring. You want
In the point we used to pinch it, then you peep in there.
Yes,
Now here I don't do that.
but you open it for buying.
I can hold like this a bit to feed it. So in the weekend I ate 2 of them. 2 or 4, I ate 4, but they were really very young. Which is okay for my teeth. but not okay for roasting, of course. I cooked them, so they are easy. So I have to apologize in advance. But I put chicken. I put chicken so you don't feel. So the magnetic field. The magnetic field. Where is Kasada, by the way? You mean yesterday you over talked about him and today you have reduced the gap? The magnetic field erases the edge. Associated with the wave. Associated with the wave. In the conductor is obtained using the expression we had, which relates the E and H. So the curl of E would be equal to minus mu Kali H by Kali T. That is the which law of Maxwell? So J K wave cross E will be equal to J omega mu H, implying that H is equal to K cross E over omega mu. The rest is algebraic gymnastics. So we do that. By the way, where my happiness for finishing here ends is where your misery for reading all this stuff starts. So this would imply that H, since it is an electromagnetic wave, it's got both E and H, so there's always a chance to extract the H from this wave. So H would be the same as omega mu sigma to the half over omega mu exponential j pi over 4, then z cross E, and then we would have H being the same as sigma over omega mu to the half exponential j pi over 4, then z cross y E naught, and then we have exponential minus alpha z exponential j alpha z minus omega t. Well, how did I end there? Because I have jumped, I think that is okay. I've jumped a step, which step is not a big deal. I've just jumped a step when I bundle everything inside here, which is not a problem. Thus, H can be given as minus x roof E naught sigma over omega mu to the half exponential minus alpha z exponential j alpha z minus omega t plus the other pi over 4 here. And when you look at this, this is equation 14. Equation 13 is for E. Where did I grabbed the E? The one of E is equal to y exponential minus alpha z, exponential j alpha z minus omega t was our equation 13. So this is equation 14. Comparing 13 and 14, what do you discover?
What is
13 is the one of E. 13 is the one of E is equal to Y roof E naught. Okay, before you go there, you first have the 13 is the Y roof E naught exponential minus alpha z E equal to Y roof E naught exponential minus alpha z exponential j alpha z minus omega t. This was the 13. Comparing these two equations, what do you realize? Try to be smart. This here, you could make this one to be H naught. Okay? So that section would look alike. It's along the minus x, which is okay, it's the direction. Then it has an amplitude, we also have an amplitude here, we have an E minus alpha z, we have A minus alpha z, but this other exponential alpha z minus omega t here we add on. And what does that make it? It will now be out of. Okay, so compare the equations. Comparing equations 13 and 14, we note that the phase difference, between E and H, between E and H in the character is 45 degrees. The amplitude of the field, of the E field, delays by a distance omega delta, which is the same as 1 over Ki, which is equal to 1 over alpha. And alpha, so the omega delta is the same as 2 over omega mu sigma to the half. This has a very special name. Yes, we have that lecturer, Dr. Dai, but when I tried to do abstract algebra, he came in and said, this is going to be for omega delta. I said, this one is not going to work for me. I left, but when we were in Norway, he came to visit, and he came for postdoc and visited us. He was a nice guy. When the nice people die, they say God loves nice people. So I don't know. Where Coronega Delta is called this distance here. This lays by this distance here. This distance here, we call it the skin depth. It's called the skin depth. And we can call it the depth of penetration. The depth of penetration. I saw someone behind excited telling somebody that I think she was seeing the notes somewhere and she was telling somebody. Is it about this, the depth of penetration? So then we have the J, K cross E being the same as J, omega mu H, implying that H would equal to K cross E over omega mu, and the H would equal to omega mu sigma over omega mu squared. If we take a half Ej pi over 4 Z cross E exponential J pi over 4 Z cross. Then we can say that the field energy would be given by sigma over omega mu all to the half exponential J pi over 4 and Z roof cross. In my notes, this marks the end of this damn course. However, there is no however. However, you know that the course, there are parts which I gave in course outline, which are not synonymous with the course outline on web, the one of the new book. Don't learn by the fact of following what is being given in the notes. The reason I fight this curriculum is that for me, I was a day scholar. I could read as much as I could find. My brothers had who were all ahead of me because I'm the last born. I'm the last born, so all of them, most of them, their books were there for me. So I would chop. I never had time to waste. I would chop this like chemistry. Those objectives in chemistry. If I read the first two words, I know the answer. Not whether it is ABC or no, I know it is a solvent or it is a solute. So I just read the first two words, I say solute. So I look for solute in the or solvent in the ABCD. Doesn't matter whether the teacher changed them. Not grammar, understanding. It is understanding. In the A level, when we started A level, I told you of the teacher who had just finished here who said, cram and go to your head and understand. I first hated him. But then afterwards I realized what he was talking about. By the time you cram something, you understand at least 10%. When you are writing that equation and writing it, like if you are writing Maxwell's equations, one time you say, but why are they now in this order? Why did they start with 1 being the curl of h equal to j plus d, d by t? Then you realize, we started from the electrostatics, then did the Gauss's law, went to magnetism, then after that went to time varying fields, and then both for electric fields and magnetic fields. So you can't cram and just cram. One time you ask yourself, what am I doing? If you are just a crammer, you reach, and if you miss one point, you are dead. I just see you looking at things like how Muzaffar was in the other course. He just reached, he looked at the paper, he said, he actually, if I had given him permission, he would have gone up. I hope you want to do the same. So I thought I would call him to my office and talk to him. But since this is not the last semester, Isaac, I think you need to... No, I wanted to call him and talk to him one-on-one, but my talking to him here will help you, all of you. I don't know, is it MOOCs activities which make you want to just focus on MOOCs and then you are forgetting books? You came to study. This is an opportunity which will never come again. I came to earn money by teaching. That's why when you see me here, my job is to teach. Period. I could also want to go to the guest house. I got a car, park there, take some cup of tea, look at a nice lady. But I came to teach. I came to serve. So I came, dive into my office, go on when Fred helped me to scan the rest of the notes for the other course. I made sure I upload them. The moment he sent them, I made sure they are uploaded. And if I behaved the way I've told you, all of you would be my darlings. I would come here and I say, you know what? I have an appointment. I will be going to Sheraton for an appointment, so be reading these notes. I want to be there this afternoon. And you always say, that is our guy. But then when you graduate, you are like, how is Mario being your guy help you when you reach in front of class and you have to chop stuff? Please, from today, Isaac, to the end of these exams, you must make sure that you pass all the courses. And from next semester, give other activities 5%. 95% your course. Whether you love it or not, I don't give a damn. They gave you this course. And we are paying you using my tax. I've marked both of your works, and I'm not impressed. It's not that I'm shaming you, but I want you, since you are people's representative on MOOCs. I saw you the other day eating food. And you are going to eat my food on Thursday. Don't refuse to eat my food. Please. And this goes to any other person. I improved. When I was working this work, there is an improvement. Okay? I don't know how you take it, but for me, any opportunity I get, I take it with one heart. And whenever I go to a place, I look for what I benefit there. When I came here, I said there is internet. is electricity. If I give time there, I will benefit. I have videos online which I couldn't have uploaded using my own money. So it was so nice meeting you. I will miss you. I will miss you so much. Those of Electromagnetism, those of Electronics and Instrumentation, we're meeting on Thursday. And then of course when we meet in the party, we don't have much that we shall be talking about in terms of the course. We shall now be, you actually will be busy telling me things which even I don't want to listen to, but you'll be yearning to tell me about your life. The chicken is there, you chop. If you want, I can even make extra, so that you chop and get tired. I get money by teaching you. I told you the story when we got a scholarship. The Norwegian woman came to see us before we left. I asked her, what moves you to jump on a plane and come to monkeys to see how they look like? She said, no, if you are not there, I have no job. I work in the international office, and if that international office has no international students, I don't got no job. You tell that to people here, whom they give a job to make sure that they give you your money, but you have to first carry brackets to get your money. How much did they give you? I want to complain for you again.
305,000.
They deducted 30,000.
For what? Subject. So, what suggestion do you give? I haven't recorded, but I have a list here so I can record and give the person. So, and then I have the. And by the way, for you, I have not marked yours. So I send Abuya Rashid. Is he here? He's not here. He's a what? He got money. 300. You get 300 and come crazy. That's my fuel for just 2 weeks. If I just come here and go here and go. Because since I have finished and I have some time, let me give those whom I have finished their work, and then those who will be in electromagnetism, sorry, in electronics I give. It's out of 30. So this is, and then the Rashid Kauma. What do you think? And Mwezi. Then Segawa Edward. It's in the order. It's the order which you are seated. It's not. That's why here. Then Sebufu, Zafaru. That is yours. This is Then Jansi, I don't see him. DJ is not here. He's making a playlist. He's making a playlist. Hajat. Mahat. Then Karu. Jonathan, and is Musingus still doing the course? You are laughing. What happened?
It's the king of the course. I've seen
Eh?
the king in the course.
Is it?
He's the king in the course.
Is the king in the court?
Yes.
This one.
Seminary Catholic.
What does that mean?
Well, seminary.
Said what I king. Then Nyombi Simon, please check through. There is then Mujumba Lisa. Go. Then Atwandine Samantha is here. Chividango, Uganda Brian, Namwebia Fireman. That's it. Others, the other bit. So only from down here, when I was marking, I mark in the order. So all of these other ones I haven't marked. Then make sure you. So do I do corrections or we wait until when I have marked? So I promise by 2 tomorrow, your papers will be ready in the office and the marks will be on the way. And so I don't know, do I need really to do any correction? State Council's law of electrostatics use the law to deduce Poisson. Then the energy, you just had to state rho V d tau and then sigma V d tau. For that, then the E is equal to 0, rho is equal to 0, the V constant, then the potential surface and E perpendicular. The other one was just having E is equal to minus V, and the divergence of E equaling to rho of epsilon, so rho will be equal to epsilon times the divergence of E. And then for the one of the conducting sphere, I did it like 3 times. That example. This video is well elaborative on Muere and whatever. So take some time and peruse through this book just to brief, just to be sure that what I taught, those are the that's the nomenclature in the book for that purpose. And then I told you these are my notes are like this. Only that this is typed, but my notes are exactly these for distance materials, and with the only difference being that I do not state objectives on each beginning of the course and on the final. So if you find I added wrongly, fine. If you find that I cancelled something you are sure is right, you do whatever. I apologize really that all of you should have gotten. But then I first made a mistake and marked instrumentation because I felt like it was better to finish it and then do this. And then now time got me. Because I thought I had been left with the part. These all other scripts I had not marked anything. Because I had an illusion that I had marked those but not finished. So, but don't worry. If you go to below 15, then you need to talk. For instrumentation, the marks are on way. But and the marks, the scripts are done, but I couldn't bring them here. This is not the forum. On Thursday I will do that and do corrections and whatever. Do you need another test for electromagnetism? You need the one for electronics and instrumentation. Okay. other, there is no logic that I use to mark people whom I mark. I marked in the order I collect them. You remember? I collect the scripts in the order, and when I'm marking, that's how I mark the work. So where I stopped is where I have distributed. That's how you were seated. Yeah. So you don't say, now why did he mark so and for me, you didn't mark me? Yeah, I didn't have any feelings when I was marking. I just marked from, and I didn't need to look for those whom I like or whom I think will pass me. So, if there are no other concerns, yes, Maharaj. There are two quizzes. There is online assignment 1 of 10 numbers, just 3 marks. And then online assignment 2 of 100 numbers, 25 per page. So you must make sure that you attempt it when you have enough battery and stable internet. If you have finished page 1, and then you are going to page 2 and everything collapses, you get a 0. And I give you a 0, because that's what the system will show you. So the quizzes are there, and the certificate is ready. Once you have finished the quizzes, and now that once I put the marks, you'll be ready to print your certificate. For electronics and instrumentation, I think it is, you are able to print your certificate already. I don't know which one is which, but I think you are happy that I'm able to finish in time. Me, I'm happy that I went, came back, and then made sure that, so there is nothing that is in this file that I never chopped here on board. So there is nothing in this file that you won't chop on the paper. You have also to chop here. Brian.
I have a constant gift.
Yes, the last one.
Yes.
Not allowed in the other person, yes?
I've enjoyed that course.
Okay.
Yes. Thank you.
That was the concert?
Yes.
Yes, I put on a university tie so that you see that I have another tie. Because I was always in the... But I had a different tie yesterday.
Yes.
Yeah, I had a small tie which is smaller and longer. It's because you are not attentive. So you didn't look at me yesterday, but I had a different tie from the tie. Maybe that's why even the camera refused. Said you are not learning, you are not going to have different things. Okay, I don't know. I feel like I shouldn't go. I should be here every time. So I miss you. I wish you good luck in your other courses in the second semester. Likewise. So good luck in your exams.